Irodov question number 1.135. A small disk A slides down with initial velocity equal to 0 from the top of a smooth hill of height capital H having a horizontal portion. What must be the height of the horizontal portion small h to ensure the maximum distance s covered by the disk? What is it equal to? So we have a hill with a height h, okay, and then it curves, and then there is a horizontal portion which is at a height small h, okay. Now a disk slides down, so although it's a disk, don't think it's rolling, it is sliding down, okay. So we can also think of it as a small mass. So it will slide down, it will come here at this, because this is horizontal, it only has a horizontal velocity when it is leaving this place, okay, and then it will follow some trajectory like this and fall onto the ground. Let's say this is the distance s covered on the ground, okay. The question is, how much should this height be so that this s is maximum, okay. So in this system of the hill plus the disk, the only external force that is working is the force due to gravity, which is a conservative force. There are no friction forces, so therefore we can apply conservation of mechanical energy, okay. So what is conservation of mechanical energy? Potential energy initial plus kinetic energy initial will be equal to potential energy final plus kinetic energy final. This is our initial point. Let's say this is our final point. Potential energy initial for mass m is mgh, because this is at a height h from the ground, okay. Kinetic energy initial is 0 because this disk is let go, so initial velocity was 0. Potential energy final is mg small h, and kinetic energy final is half mv square if the velocity is v here, okay. So from this m we can cancel, v square we can write as 2g h minus small h, or v is root over 2g h minus small h, okay. Now let's say it takes time t to reach from here to here. So in time t it will cover a distance of height small h, and it will also cover a horizontal distance of distance s, okay. So we can write h is half g t square, okay, and we can also write s is, there is no effect of gravity on this velocity because this is horizontal velocity, so this will be vt, okay. So from here we get t square is 2h by g, or t is root over 2h by g, and from here we get s is vt, so v we can write 2g h minus h times t is root over 2h by g. So we can cancel out the g's, we can take 2 out, this becomes h minus h. Okay. So this is the distance s. Now, for s to be maximum, we need a ds dh to be 0. Now, we can actually skip this step because it's pretty obvious from here. S will be maximum when h is half of capital H. Okay, but you can also get the same result doing this. So h will be capital H by 2. Okay, so this is the condition. And what is the value of S max? The value of S max will be 2 root h times, or h by 2 times h by 2. So S max will be h. Okay, so this is our answer.